Hello everyone, I'm Teacher Sunny, and today I'm here to explain another problem for you. So, the problem we're discussing today is this one. Is it still about fraction applications? Yes, we're still talking about fraction applications. The most important first step is to read the problem carefully. So, let's analyze it. A batch of parts is being produced. On the first day, 1/3 of the total plus 20 pieces were produced. On the second day, 3/5 of the remaining parts were produced and 40 pieces were left. The question is, how many parts are in this batch? When reading the problem, if you don't understand it, read it a second time. Read it sentence by sentence. Understand it one sentence at a time. For example, the first sentence says, produce a batch of parts. So we know there is a batch of parts and this batch is a constant. We need to identify the constant, right? Then, on the first day, 1/3 was produced. In other words, this entire batch of parts can be evenly divided into 3 distinct parts. So on the very first day, precisely one of those 3 equal parts was produced. Therefore, we can accurately translate it like this. We take this entire batch of parts as one complete unit, just simply treat it as a single unified unit. Why do we still consistently use one as the fundamental unit? Because it's still essentially a constant. Basically, we always use the constant as the primary unit. But if it's a variable, if it's just a variable, then you absolutely cannot treat it as a fundamental unit of 1. Because the unit 1 is actually a crucial reference value, a significant benchmark. And you simply cannot just edit this important benchmark at will. All subsequent changes in the constants will be meticulously compared against this established reference value. Alright, so on the first day, 1/3 was produced. In other words, this batch of parts can be evenly divided into 3 parts. Just draw 3 triangles to represent it, that's enough. Alright, so the event is actually just the very first day. The production of this batch. 1 out of the 3 parts of this batch of components. Add 20 more. If we need 20 more, we just add them in and then add another 20. Alright, don't forget, if they produce this much, there must be some left over, right? Because the amount produced plus the leftover amount equals the total amount, which is 3 triangles. So there are still 2 triangles left. Minus 20. Because the production amount plus the leftover amount must equal 3 triangles. Alright, that's clear. Now, let's look at the second day, when they produced the remaining 3/5. So on the second day, what they produced was what was left from the first day. So, the delicious leftovers remaining from the conclusion of the first day can be meticulously divided evenly into precisely 5 distinct and equal parts once more. In other words, we can effectively split what is still left over from the initial day's activities into 5 perfectly equal and identical sections. So among these 5 distinct parts, on the second day, they successfully produced 3 of them. So that means there are still 2 parts remaining. Out of a total of 5 parts, exactly 2 are left. So how much are these 2 parts worth? The problem statement tells us that there are precisely 40 left. 40 pieces. So it's very easy for us to understand this. This means that one specific part is 40 divided by 2, which is 20. That's it. We have successfully solved this particular problem. Alright, now let's carefully look at the next part. Over here, look, there's an equivalence relationship here, which is very important. This equivalence relationship is the parts left after the first day. What about the parts? The relationship goes like this, okay? There are 5 circles, and we already know that 1 circle equals 20, so 5 circles is 5 times 20, which equals 100. So that's exactly 100, and from this point right here, add 20 to the left side of the equation, and add 20 to the right side, so the overall balance remains perfectly balanced. That means 100 plus 20 equals 120, therefore one triangle equals 120 divided by 2, which is then split evenly into 2 distinct parts, resulting in 60. One single part represents 60, so that's 60 total parts. So once we've calculated this, we've solved it, because this batch of parts takes a total of approximately 33 hours, so there are a total of 3 distinct triangles. So if one individual triangle is 60 degrees and there are indeed 3 such triangles, then this entire batch of parts totals 180 degrees. We've successfully figured it out. Did you truly get it? If you did, please kindly give Teacher Sunny a like, follow, and share this with more friends so we can all learn together.